Okay. Okay, great. I think everybody's there. Let's just start. We want to talk about from Java to Scala in 2 months today. What does that mean? We have a simple agenda, so we want to explain a little bit how Java developers can learn Scala. We think that you can only learn technology if you're using it every day. So I think when you're just spending time on the weekend or after work and you're just reading some papers, then you usually don't learn something very well. So you have to do that in your daily business. So you have to convince your team and your manager to use this kind of technology. And we want to provide some answers how you do that. The third thing that we want to provide is some tips when you're starting to learn Scala. And the fourth thing is how can you introduce new technologies, I think a little bit in general. That's more something that will deep dive into mythologies and just, mythologies, how you can introduce new technologies. The fifth thing that we want to explain is why we've chosen Scala. I think this is a little bit important because, well, we could also, other people are maybe more interested in from Java to Clojure in 2 months, but we want to focus here on Scala. And the sixth thing, which is maybe the most important thing, is you can do that while having fun and being productive, so you can provide value. We want afterwards explain, well, afterwards you should know that you can do that and the risk can be calculated and you will be productive. Okay, there are some things that are not on our agenda today and that we won't make technical deep dives. So we won't speak about that or that library in specific and how it works and how you can use it perfectly. And we're not trying to evangelize you. So this is an approach that worked for us. It's something where we can say, okay, this is proven, this is okay for us. We would repeat that like that, but there are other people and other circumstances, other contexts, and of course, you have to take that into account, and so we're not trying to promote things a little bit too much. Before we're going into the subjects in detail, we're just introducing ourselves a little bit. So my name is Daniel. I studied mathematics and physics. I've done some work as a contractor, and I founded an online video advertising once. But since 2010, I'm working at Zalando. And I'm there currently, I'm responsible there for logistics and parts of our self-written ERP. The reason why I'm a little bit here is because in January or end December, we started a project that I was leading that introduced Scala for a curated shopping platform at Zalando. Okay, Akko.
Hi, my name is Alexander Kops, or Akko as many people call me. I'm the delivery lead for the brand solutions department. I'm also, since 2010 at Zalando, started as a PHP developer, then switched to Java, did a bit of Ruby and so on in the meantime, and since 1 year I'm now in the brand solutions department, and I will detail a bit in the second part of this talk that how we in the brand solutions department chose Scala and implemented it. So see you again in the second part. And back to Daniel.
Great. Okay, some words about Zalando because some people of you won't know it. It's an online fashion platform, the leading online fashion platform in Europe. We're operating in a lot of countries, 15. We have 15 million users, and we made an IPO last fall. It's one of the most successful companies in European economic history, which is, kind of important. Zalando Tech, we have a headquarter in Berlin. We have 700 people working there, plus. What are 700 people doing there? We're producing all software nearly in-house. So that means that we're not buying, in general, very big bunches of software. The reason why we're not doing that is because we are thinking that when we're buying something from the market, it doesn't give us a competitive advantage. We're thinking that technology is absolutely key for our business, and that's why we're doing everything in-house. We have a strong focus on data science and machine learning, so you can imagine that, well, most tasks are operated automatically. So something like price calculations, what are the appropriate prices for an article, that are things that we're doing, in our case algorithms are doing. And we're planning to hire 2,000 engineers until the end of 2016. Yeah, well, you will hear this hire word maybe more often during this conference. Okay, but let's now dive deep into why Scala. So I think the first thing that I have to explain a little bit is where we're coming from. So the company was founded in 2008. We had a PHP shop that I cannot recommend to anyone. You shouldn't use Magento at all. So we rebuilt everything in 2010 in Java. And in 2012, we rebuilt it again. And since then, our code base has massively grown. We have a quite homogeneous tech stack. That means in 2010, somehow, we decided to use this technology stack. And since then, it was copied over again and again and again to more and more services. So we're basically using Java as web application in a Tomcat. We're using Postgres databases, in some cases with stored procedures. And our services, so we have a lot of services, they're communicating mainly via SOAP. That is, let's say, a little bit the past. We're having a lot of dependencies that are bound together by Maven. Okay, so we have a quite successful company. We build a lot of stuff in Java. Why are we now hitting off to something like Scala? And I think one of the reasons are that Java has some limitations. This shouldn't be a Java bashing talk. Honestly, it paid my flat for some years, so I'm highly grateful to the good people of Sun that they once created that and that Oracle is continuing that, but there are some limitations. One thing is, and I think this is for me the most important thing, it's the development lifecycle. So when you're using Java, you somehow use quite often, or at least in our case, we're using also some Spring. So you're typing in something into your editor, and then afterwards, afterwards you just want to see whether this code is running. So you have your unit tests, you have your container that is continuously restarting, and that takes just time. And this time is decreasing your productivity and fun. So you just spend more and more time wasting just watching in front of your console and watching Maven do its job. The second thing is, I think that's obvious. Java produces some boilerplate code. So I don't know how many of you have developed in Java, but you have sooner or later, well, in many cases, you have these domain objects. They're more or less beans. They're just consisting of getters and setters. Then you have some DTOs. Then you have mappers. And when you do that in Scala, you have just, well, one case class and a formatter. That's just less code. You can express things that are maybe expressed in Java in 400 lines in 5 easily. The third thing is that what I don't like about Java is that that you cannot do scripting with it. So though I'm really not a very experienced Python developer, I'm doing scripts in Python and not in Java. And honestly, I'm not bad in Java. The fourth thing is requests are bound to threads based on the servlet specification. So whenever a request pops into your Tomcat server or whatever servlet container you're using, this request is heavily bound to a thread. And the thread is a very, let's say, expensive resource, and that leads to point 5. And sooner or later, you find out that your computers that are running your code have very bad CPU utilization. So once you run your code, you have a lot of service, and then you find out, oh, okay, I need more service, but the CPUs themselves are not very well utilized. So you can start then afterwards parallelizing things, and then you're running into deadlock problems or race conditions and things like that. But that are just limitations of Java. So when you're thinking now, okay, we have all those services where we think that we found some disadvantages in Java. What are potential alternatives? Obviously, there is not only Scala, there is also Python and Ruby. I'm pretty sure that a lot of people who are programming in Ruby or Python will kill me for this sentence, but for me, they're looking quite similar. They don't provide a very deterministic programming model to you. They're quite open to do whatever you want to do. They're dynamically typed. They're not very well, you can parallelize things there as well, but there are some limitations in the language implementation itself. So, for example, this global interpreter lock makes things a little bit harder. Then there are also other alternatives, Clojure and JavaScript, I think. They're quite hyped. People like it, at least. Well, in my circle of friends, a lot of people are explaining to me, you should do everything with JavaScript. We don't need all the rest. And other people like Clojure a lot, so it's more emphasizing a functional programming methodology, both languages, and I think both of them are quite well. The thing is, I once developed for, I think, 2 years in Ruby, and I have to admit, I think I was never as productive as in that time, because when you're programming, but the context in which I did that was I was programming mainly alone. So I founded a company, and I was doing, I think 90% of the code was written by myself. So, and I felt quite good with that, and I knew every use case, and I think and based on my experiences afterwards, I was never as fast as in Ruby. And JavaScript is, I think, quite nice as well, but there are some limitations there as well. So I once worked at a company that had in 2000 or 2001 the glorious idea to create an extremely full-blown web interface. It was extremely fancy. This was the time before jQuery and things like that. So they had model dialogues, they had tree navigation, they had drag and drop context menus, all this stuff that now is quite easy because it's already solved for you. But this thing had to be done all by hand. So we had David. David was the JavaScript developer in this company. He produced 100,000 lines of JavaScript code. And then we thought, there is only David who's writing that code. What happens if David leaves? So what the people there tried to do was that they threw more people on that topic, and nobody was able to work with it, to extend it. It was really something, where you're thinking, So they were all smart people, but it's just hard to deal with all those lazy dependencies in a functional language when your code base becomes so big. I think the same thing could occur with Clojure as well, especially when you have macros, and you can do some crazy things with that. And the third alternative is Scala, and we're here at the Scala Day, so I will concentrate on that. I think all those technologies are useful. All those technologies are great. I think I worked with all three of them, and the most important thing is that you have to understand for which use cases are they good. I think when I'm thinking about programming languages, I'm thinking that you have several modes where you can apply them. You can apply them when you're working alone, when you're working on a microservice that maybe consists of 80 lines of code, and you're maintaining that all the time. Then this is something different than when you're working on something that has 50,000 lines of code or even more. This is something different, or whether you work on something alone or in a group of people. So I think that when you use Ruby or Python, I think it's very well when you work alone on something and when you're working on a monolith, but not very well for microservices because you need the asynchronous yeah, some reactive patterns, let's say. And those reactive patterns are harder to implement in Ruby or Python. I think they're easier to implement in JavaScript and Clojure, but there you have the problem if you're working with a lot of people on something. I think Java, yeah, the productivity when you're working alone is not very well, and the thing that is here at the Microsoft, that's a tilde, because I think it changed. It's not a minus, it's not a plus on the, for the microservices. It's more or less something, yeah, in between. I think Java 8 did a good job. You can do more things, but you have still the thing with the thread. So still threading is a little bit, is just harder because of the servlet specification. Then you have Scala, and somehow it fits for us very well for all use cases. I think that are basically arguments. But arguments are harder, are just things that are convincing people. So we're mainly selling fashion articles, so for us it's harder maybe to motivate developers than if you would work for the NASA, for example, and you're flying space shuttles. I mean, developers are by nature not that affected by fashion. And that's why we are having, let's say, an approach that we're naming Radical Agility. We implemented it in the beginning of this year, which basically says that the main entity that makes decisions are teams. So those arguments are quite nice. You can present them to people, but our teams are deciding their technologies by themselves. And in our case, somehow they prefer Scala. So at least the new well, some of them are also preferring Clojure, but the teams that we're talking about are preferring Scala. Okay, great. So now some slides about how you can introduce new technologies. It's a little bit a general approach. I think I'm a little bit an old school guy, so I always start with requirements. I don't know why. Some people are doing it differently, but yeah, I always start with requirements. So I think when you're learning a new technology, you will make mistakes. And I think to know that in upfront is quite crucial when you're making your decision when or how to introduce a new technology. So you should consider that your mistakes are not too costly and are not affecting too many people. Why should you? Costing money, I don't know how many of you have already sit in front of a monitoring screen and seeing houses burn down. So that you know, okay, after half an hour we've lost 500,000, after 1 hour we've lost 1 million. It makes, I can tell you, I've done that too often, and you don't want to do that. So you can sleep better and feel better and have a higher self-esteem if you're not doing that too often. Otherwise you're thinking, I'm more or less not enhancing the world, I'm more or less destroying the world. So you should consider not to integrate new technologies in the most crucial parts of your application. The other thing is, I think it's also quite important not to affect directly too many people, because then first of all you're annoying some people. I mean, and you're creating also a spirit that doesn't support in the future implementing new technologies. So if too many people seeing you failing, it destroys a little bit the courage, the motivation of people. So you should choose the place where you're introducing new technologies wisely. Well, you need a team for implementing new technologies. I think it's always better not to introduce that by yourself. You're making mistakes, and usually other people are interested in things as well, and if you're integrating them, you're creating a much nicer spirit, and you can learn from each other. And the third thing that you need is time. Sounds stupid, but obviously it's something that you need. Okay. Well, when I think, what is, let's say, the best scenario? It's a freshly founded startup, honestly. I'm pretty sure that a lot of founders or your business guys that you're maybe founding a company are thinking, no, we don't have time. But I personally think that if you don't have customers, it's easier and you have more time. If you don't have 400 buyers or sales guys or marketing guys sitting behind you, it's easier to implement things. But obviously not everybody here is tomorrow or yesterday started in a freshly founded startup. So there are also possibilities to do it somewhere else. Those 3 points are, I think, quite crucial because you have I think, basically you're learning things by 3 different methodologies. The first thing is you learn by mistakes. I think, well, when you're touching a heater and you're burning your fingers, you don't do that very often. You learn by copy-paste. You're just adopting the behavior of your parents or of your colleagues. The guys who are smart in the room, you're usually copying their behavior. And the third thing is by thinking. This is the hardest thing. Try to work in an environment where the first 2 things are very well. The thinking part is the hardest. And yeah. So how would I set up? How are we setting up things when we're introducing new technologies? We're selecting a project. So the first thing you need a scope where you can introduce a new technology. So you should take something. I would choose something like a leaf application, something that doesn't have too many dependencies, or ideally where nobody's depending on it. So I think this is the best thing to introduce in new technology. So yeah, some front-end application, for example, or a system that is used maybe internally, and that has also, let's say, that doesn't start with the highest non-functional requirements. I think that is quite important, so that you have something that you can ramp up and learn with the project itself. The second thing, you should choose a team, of course. So how do you do that? I think you have several criteria that you can use, but the most important criteria for me is motivation. Honestly, a guy who is motivated will compensate a lack of knowledge sooner or later, over time. I think when you're selecting the team members who are there, it's quite important to pick the guys or pick the girls who are women that are most motivated. I think that's important. The second thing, what you need is definitely, you have a lot of integration stuff to do, so you should have one person with a strong DevOps mentality there. You have to set up a lot of tooling, you need deployment, you need continuous integration, you need build systems, and all that stuff you have to do. Yeah, you need one of those persons, and you should have one person who is really something like a driver of that technology, because he will be then sooner or later, he will a little bit drive this project. Then, when you have a team, you have a project, and then we are usually starting with something that I call the grooming phase. So this is the phase where you should close your doors and don't allow other people to come in, because this is the part where we're ordering books and sitting together and watching YouTube videos. Doesn't look too professional if too many people are coming in and asking, what are the people doing, Daniel? Come on. They're constantly only watching YouTube videos. Some people don't understand that. This is why I highly encourage you to separate those people somewhere. Some people... You can explain that, but it's just a waste of time, honestly. It's better just to separate, yeah. In this phase, I usually like it to have something like 1.5 weeks where you're just reading. And then afterwards you have some topics, like really continuous integration. You need some kind of an OR mapper, maybe. You have topics that you want to address before you start implementing things. And you should collect all those topics and assign them to people, and then let them provide some templates, try to play around with them for some days, and then they're presenting their results. And then you go into the implementation phase. And honestly, I think in this implementation phase, it's quite important to concentrate on the thing that you want to do. Honestly, you've done your preparation, and if you're rethinking everything constantly, I think you're not having enough success moments. I think it's important that you're just producing something, and then other people are clapping maybe, or saying, okay, it goes forward, that's great. And then you will start believing a little bit in the approach, and you don't question everything in general. This is a phase where I don't know how long it is, depends a little bit on the project, but in our case, our grooming phase was 3 weeks, and our implementation phase was, I think, 5 or 6 weeks, something like that. And then afterwards, after you've implemented, you're doing a retrospective. I mean, then you're thinking, okay, now we're all so much cleverer than we were 5 or 6 weeks before, and now let's note down the things that we've learned and that we would change in the future and make decisions when to refactor things. I think you shouldn't do that constantly, otherwise you're just not having enough success moments. I think when you're introducing new technologies, it's also important. Then you have some kind of this special team that is responsible for it. Okay, yeah, okay. It's important that you're integrating others. So be transparent what you're doing. Provide contact persons to others so that other people who are also interested in this kinds of technologies have the ability to ask questions and to see the status of things, and provide space for knowledge exchange. Okay, that's it from my side. Now Akko will explain a little bit something how this looked practically.
Yeah, thank you. This goes a bit more into detail now. As I said, I'm delivery lead for the brand solutions department, which is one of the newest departments. So basically, it's a startup inside of Zalando. So we fit that criteria of Daniel. So we are a new team, and we built new tools, basically for our external brands and merchants like Adidas, Nike, and so on. You know them all. So our first product is a CMS where they can edit their stuff on Zalando, basically themselves. And we provide an analytics tool there where they can see how their customers behaved on their pages there. And soon we will implement some order and article management because we want other people to sell stuff on Zalando. So when we wanted to write this analytics product, I took the opportunity. I was basically encouraged by our VP of engineering, Eric here, that he said, well, try out Scala, it's cool. And I said, well, cool. Then I take the Play Framework and Scala and make a little prototype of it to get a feel for it. And I had no prior experience with either of them, so I was doing Java basically before. So why we tried Scala in the first place, of course, runs on JVM. All our stuff is already there, so we can use our libraries that are there if needed. And Play has also very good reputation performance-wise. And since it's an analytics product where we will probably have to crunch numbers and gather stuff from different sources in the future, I thought, well, Scala is a functional programming language, and we might want to parallelize all this stuff in the future. And yeah, so functional programming seems to be a very good choice there. Okay. What convinced us in the end? So it was not that guy, although he looks very convincing, I hope. So first of all, the concise code you produce with Scala. So especially, as Daniel said, with all the boilerplate that Java developers have to suffer, give them case class, give them pattern matching, and all the cool collection functions. And you have like a tenth of the size of your code base. So that makes us as developers very happy. It combines, of course, function and object-oriented features that makes it fairly easy for Java developers who especially have no functional programming experience before to switch over. So that's a fairly good argument to go to Java developers and say, hey, you can try it. You don't need all this functional stuff just yet, but you will get there eventually. All the clever design choices in the libraries, I mean, like, for example, the options by default, so you don't have to fight this dreaded null pointer exceptions anymore. So this is very, and the clever features that are in there. A play is very simple. If you have used Ruby on Rails, for example, you immediately would see the similarities there. You see how you define the routes and the model view controller pattern and so on. So it's, from most people, very simple to grasp and to jump on it. And also the general ecosystem around Scala and Play seemed to be very mature. So I was able to find, for most of my questions on the internet, the answers. There were very mature libraries. So that made a very good impression to me. Also, TypeSafe itself is dedicated to provide a complete stack from front to end into the database to have it all non-blocking. And once you drank that Kool-Aid and see stuff is non-blocking, you wanted to have it everywhere. And then, TypeSafe is doing a very good job fostering that. But it also has a very steep learning curve. So you have to learn, of course, a new language, which is Scala, which is probably the least problem, because it's quite similar to, or you will immediately recognize most of the parts of it. But the functional programming concepts, this is something when you just did object-oriented programming for your whole life, it's kind of, you have to twist your mind around it. So till you start thinking functional, that can take a while. So this is something that definitely needs time. Of course, the new frameworks that Scala provides, and also the build tool. So quite a bit of things to learn when you just start freshly. So how do we help our developers in the transition? Daniel covered a bit of it. So we give everyone who starts on our team basically a 2-week period where they can exclusively sit down and do Coursera courses, try to get into the grip the language. We also encourage people to learn on the job, so it's totally perfectly fine if you read a book while you're at work to get yourself up to speed and learn new stuff. So that should be, of course, backed by management, so you cannot start doing that. But Zalando encourages that. We also provide some books. For example, what I found particularly valuable was Scala for the Impatient. I learned very quickly through that. Tutorials, online courses, of course, Coursera. You've probably all done that. So even one of our developers then said, well, I'm starting a learning group, and he organized it himself. So he just invited everyone who wanted to learn Scala to watch the Coursera videos together and discuss about it. It was pretty nice. Let them write simple prototypes first. It's also okay to cheat, so you can hire experienced Scala freelancers to get their thing going and have some knowledge transfer. So, in fact, I see one in the audience there. Hi. And what I discovered when our team started to do Scala was I saw two types of programmers basically. So two extreme types. One is that people that just write their code like they would do in Java, not embracing any functional stuff yet. I think it's perfectly fine. So you can do that. You will get into that eventually. So the best way to foster that is just go into your code review tools and encourage them to use something more functional, and eventually they will see the beauty of it. I'm pretty sure. So those people, you see many ifs in the code and all this for loops, the old school ones. So yeah. So That is okay, but you should be strict about the immutable collections. Yeah. And the other part of the spectrum is what I think Eric Meyer would call functional programming hipsters. They want to go deep dive directly into and use all the cool stuff and introduce Scala Z as in the first place. And yeah, after like 2 days, nobody can read the code, especially those guys who are pretty new and more slowly to embrace that stuff. Yeah, you should hold their horses there. Tell them you ain't gonna need it principle, because they usually like abstract everything, and yeah, these guys need to be a bit more hold by the line. Of course, what also will occur is the wild coaster mixes. As you know, Scala is not a very opinionated language, so you can do stuff in many ways. And there will be some, many ways to do the same thing, basically. Eventually, so if you have enough time and enough, there will be coding guidelines emerging, because people will just see that then and discuss about it, but it takes a while. So for the start, if you want to introduce Scala, I would recommend using existing ones, so Effective Scala by Twitter or the PayPal ones. You could just take them and change them as you need, but that will prevent basically the wildest things from the beginning. So what I also found, that there were many people ranting about SPT. I said, well, why do I need another build tool? Can I just use Maven or Gradle or whatnot? Well, but I usually say, well, it makes SPT is very powerful and cool, and it makes working with Scala very productive because of this recompiling of the things you just changed, which is a great help. And also what I've learned basically afterwards is, because I'm a hands-on guy, I just deep dive in and start typing and using it. And in this case, Eric was right. He said you should read the manual first. So this gives you a very good grasp at the tool and grasp at the capabilities that it has. So when you initially look at it, it's kind of off-putting, but tell the people to go to the manual and they will see the power of it. And for me, or at least for all my colleagues in my team, IntelliJ grants the best Scala support. So I'm a NetBeans guy myself. I'm kind of sad that the Scala support there is not there, basically, or shitty. So I had to switch to IntelliJ, but it's good. Now a few words about hiring Scala developers. So there are a few on the market, so you probably are Scala developers, but not on the market, I guess. But most of them work as freelancers. But the good thing is there are many senior Java guys who really want to learn that. Mostly they're like unhappy with all the drawbacks of Scala at a while, and then see what of Java after a while, and see what Scala grants them. Most of them already did the Coursera courses and learned stuff themselves, but and they're very eager to use that in their daily work. So you should get the word around that you're doing Scala, and I'm pretty sure you attract good Java guys that want to use it. And if you have the resources, give them the time, as I said, to onboard and get full into Scala, and you won't see the shortage of Scala devs around there. So basically, go to Scala meetups and tell everyone we're doing Scala, and that really piques the interest of people, because usually there are many Java devs out there and they really want to do Scala, but there's not enough jobs out. Or many companies are doing it. So just one word for the outcome of our project that we did. We have now 10 engineers that transitioned to Scala. Most of them came from Java, but also one from C# and one from Python. So they are all very happy about the language and what it grants them. We created, in the meantime, like 4 new Scala applications using Play or Spray and Slick and Akka. And another bunch of Java developers are happy to, or are waiting to rewrite their existing Java application, so they can't wait. Couple of freelancers that helped us to start the project, and there's movement in all other parts of Zalando of people who really want to get on board and see how cool it is. So there's quite a bit of a peaked interest now, and as you said, teams can decide themselves what technology they use. So I guess we have a good set a good mark there, and have sparked the interest of the other teams. So, and here's just one quote of a guy in my team, David. He's the former C# developer, and this was basically in reply to this blog post. Some of you might have seen. The honeymoon is over with Akka, and he's just basically said, I'm personally in complete honeymoon love with Akka at the moment. Must be the most positively biased guy about it right now. So he's really jumping up and down and is mega happy about Scala and Akka. So just to give you a short glimpse on how it looks like, just because I was just talking about it, the one product we built is a user service for our brand. So this is just an example here, which is basically based on, so the front end, to be honest, is all AngularJS, so nothing there is rendered in the Scala backend, but the backend is basically a REST application who uses Spray and sits on top of a ForgeRock authentication solution. So that is that one thing. And the other thing I want to show you was is our insights, our analytics product, which basically is a Play, are 2 applications. One Play application which provides the REST backend for this front end here. And uses Play and Slick to store data and then give it out, and then another completely Akka-based application which we basically use to make it very resilient. So we query Google Analytics all the time, and to make it basically, if something goes wrong, then wait a bit longer and retry it again, and if you're done, then send a message to some other guy who saves the stuff. So that works pretty well, and it also uses Google BigQuery in the background to get all the stuff. So that was my part here to show you what's going on in our brand solutions department, how we are switching to Scala. So
okay,
I think it's time.
We used all 45 minutes for ourselves, but honestly, there is a microphone, and we're happy. If you want to ask some questions, then I'm pretty sure that we have still 5 or 10 minutes for you.
So my organization recently switched over to Scala as well, and one of the things that we struggled with was the tremendous amount of technical debt that we generated when we were first doing that transition. And we brought in tools like Codacy and S-Coverage, and we got really aggressive with our testing strategy to try and ameliorate that. But that initial, 3 to 6 months, we really dug ourselves deep. So I was wondering if you guys had experienced something similar, and if you had come up with techniques for mitigating that.
Well, I think in our case we did one thing that we did is was the stuff that we did in brand solutions. One thing we had now hired 15 people who are now also for another product where people are moving to Scala as well. I think the point is you will do that with every new technology. I think in general, the thing that you can do is to split things up so that they're easily rewritable. I think that is one of our approaches. So tending to have smaller, for example, play modules, and then rewriting those play modules. And of course, yeah, we have exactly the same thing, but I think we don't know how to avoid that. What? Yeah. What helps is that you have some people who know that better, but honestly, yeah, it gets rid of the biggest mistakes, but sooner or later your code will be in the beginning not the highest quality. But I think if it's rewritable, if you can exchange it afterwards in small steps, then you're on the safe side.
Sorry, how much choice do the individual teams actually have regarding the technology stack now? Can a team just say, hey, we want to switch over to Scala, so we have to rewrite several modules here?
I think, well, with great power comes great responsibility, right? So they have to. I mean, somehow we all have to deal with reality, and if there are good arguments to do that, yes, they can. And if not, they can make a plan how to transition towards that future. But in general, I would say you have to align. I mean, sometimes you're dealing with reality. Reality has also some demands on you, and I think you get more freedom if people are trusting you, and if you're acting like let's say a little bit egoistic, then people are not trusting you, and then you have let's say not that easy. Then it's just harder for you to make harder decisions, or when you're making mistakes, then people are not really trusting you. So I think you have to align it. But in general, yes. But maybe not at the moment. Sometimes you just need a plan.
Okay, so another question.
You mentioned hiring senior Java developers who want to transition to Scala. I would argue that, say, Ruby and Python are closer to Scala. They have more of the concepts in the language already than Java does, at least before Java 8. Do you have any experience transitioning people from languages like Python, Ruby, JavaScript to Scala?
I actually hired a Ruby guy recently, so he's also very happy. But it doesn't mean that people that are writing code in Ruby also use functional idioms there. So you have to take a close look on how they use the languages there. But it's totally possible. As I said, we have one Python lady there who's transitioning, and one Ruby guy who's transitioning, and so we definitely don't look only to Java developers, but they are kind of, because of this JVM stuff they did before, they're kind of like more likely to apply to a position for Scala.
I think one thing that we want to say afterwards in general is that it was absolutely successful, honestly, and it was surprisingly successful for us. That we could start with new projects and we were productive after 2 or 3 weeks. So people were producing value. I think it depends a little bit on the people that you have in the team and what are their prior experiences. It helps when they're having a stronger functional background. But at the end, if they're motivated, if they know what they're doing, and they really want to do that, you shouldn't have less fear than expected. And I'm a really paranoid person. Honestly, I'm really, I mean, the one thing that drove me to that decision, or let's say to encourage that decision, was, well, if we're not doing it there, where are we doing it then? So it's not a very positive motivation. So I'm really pessimistic. I was totally surprised after 3 weeks how productive the people were. So I think if you have further questions, we're out in the lobby because sooner or later they're gonna throw us out here. So I think
thank you for your patience and your time, and enjoy your lunch.
Okay, thank you.